దిస్ ఈజ్ అల్పన. మీరు చూస్తున్నారు KAB టెలివిజన్. వెల్కమ్ టు ఈ క్లాసెస్. మ్యాథమెటిక్స్ అంటే వణికిపోయేవారు ప్రత్యేకంగా ట్యూషన్స్కి వెళ్ళి మరీ నేర్చుకునేందుకు ప్రయత్నిస్తారు. ఈ తరహా వారి కోసమే KAB టెలివిజన్ ప్రత్యేకంగా ఈ క్లాసెస్ నిర్వహిస్తుంది. ఈ క్లాసెస్లో కలిగే సందేహాల నివృత్తికి ఈ ట్యూషన్స్ కూడా ప్రారంభించబోతున్నామని తెలిపేందుకు సంతోషిస్తున్నాం. ముందుగా ఇవాల్టి క్లాస్లోకి ఎంటర్ అయిపోదామా? డియర్ స్టూడెంట్స్, గత ఎపిసోడ్లో మ్యాట్రిసెస్ చాప్టర్లోని క్రామర్స్ రూల్ మరి గాస్ జోర్డాన్ మెథడ్ గురించి తెలుసుకున్నాం కదా. ఈనాటి ఎపిసోడ్లో మ్యాట్రిక్స్ ఇన్వర్షన్ మెథడ్ గురించి క్లాస్ చూద్దాం. ఈ క్లాస్ను మ్యాథమెటిక్స్ బోధనలో విశేష అనుభవం ఉన్న డి శేష్ కుమార్ గారు తీసుకుంటారు.
Now I am going to take one example based on the Crammers rule. So already we know that to solve the Crammers rule we are applying the method as by discussing the delta 1, delta 2, delta 3 and delta. Right, let us consider one example and based on that we may work out it, then you are able to understand very easily. And this is a very simple question also and important question. It should be almost all every time it will occur, so try to read it carefully. So here let us suppose you considered given solve system of equation by using Crammers rule. They specified it. Already we are discussing that in every examination the question will be mentioned properly what method you have to do. If they won't mention, you do your own way. That means there are the three ways. Either you may done the inverse matrix method, or you may done the Crammers rule, or you may done by using the Gauss-Jordan method. Right. So he specified try to do only by using Crammers rule. Right. The question is especially x minus y plus 3z is equal to 5. Again, the second equation is 4x plus 2y minus z is equal to 0. Again, minus x plus 3y plus z is equal to, you have that is 5. Right. These are the cases what we have now. X minus y plus 3z is equal to 5, minus x plus 3y plus z is equal to 5, 4x plus 2y minus z is equal to 0. So this is a system. We have to solve this system by using Crammers rule. Right. By our discussions, first I would like to convert this entire system into matrix equation form. I would like to convert into matrix equation form. That I am writing like Ax is equal to B. Here A is nothing but coefficient part. Coefficients are 1, minus 1, 3, 4, 2, minus 1, minus 1, 3, 1. It is the matrix. And again we may write x, y, z. Again B is there. That B is 5, 0, 5. This is the part. So this will be the Ax is equal to B. It is known as the Ax is equal to B matrix form. After this we have to evaluate delta. I think you know that delta is nothing but determinant A. Delta is nothing but determinant of A. That is determinant of 1, minus 1, 3, 4, 2, minus 1, minus 1, 3, 1. So this you have to expand. Now while discussing here only I am giving the some more concept here how to solve a determinant also. How to solve a determinant? I think to solve the determinant you can expand either by column or by row. So now first I am expanding this determinant by using the first row. By using the first row. Here we took like this. A sign rule is there. Sign scheme, what we call this as. Write the plus, minus, plus. Ignore these signs, but these are the special signs. Plus, minus, plus. With that scheme, I may write like this. Here, I used to write these values. I have to find out the A value and B value and delta values like this. So, in this case, we may expand this part. We may expand this part by using this formula. Here, delta is equal to what I can write 1 into eliminating this row and this column, what we get 2 plus 3, that is 1 into 2 plus 3. Again here minus, but here already minus 1 is there. Eliminating that row and that column, what we get 4 minus 1. This I am writing like this, 4 minus 1. Again plus 3 into this value, 3 into eliminating this row and this column, there 12 plus 2. This is the part 12 plus 2. So from this what we get there, it is 5. Again it is plus 3. You remember that 4 minus 1, 3 minus half minus. Again 3 14s are there. That is the 14. 3 14s are there. So 14 can be written as divided, that as 442. So completely it will become delta is 50. So you got there delta as 50. So this is the expansion. Once again repeating here, eliminating 1, taking this row, 1 row is eliminated, 1 column is eliminated. This is AD minus BC, that I am writing 2 plus 3. Again minus of minus 1, taking this eliminating this column and this row, I get there 4 ones are 4 plus 1, that I am writing there minus of minus, 3 minus are there minus 1. Again plus 3, 12 minus of minus 2, that is 12 plus 2. So finally you got delta as 50. Right, delta you got it. Again you have to create the delta 1. How to create the delta 1? The delta 1 can be evaluated as like this. Except the first column, rest are as it is. So you eliminate the first column with the constants, that is 5, 0, 5, minus 1, 2, 3, 3, minus 1, 1. This is delta 1. Okay, you got the delta 1. When you got the delta 1, you have to evaluate the delta 1 also. Similarly, our previous sign scheme only we can apply. This is here plus, minus, plus. So this can be expanded as 5 into eliminating this row and this column, you get it as 2 plus 3. Again minus of minus 1 into eliminating this row and this column, this I can write 5. Again plus 3 into eliminating this row and this column, you get there 3 zeros, this is minus 10. So you got this part as like this. Here 5 into 2 plus 3 minus of minus 1, what will be the value we may write? This I may get 5 5s are 5 into 5 plus 5 minus 30. So clearly it becomes 0. So delta 1 is 0. I got the delta 1 as 0. Right. Now I have to write the delta 2. We got the delta 1. Then you create the delta 2. So delta 2 I can create by using like this. Simply remove the second column and substitute it by the constants. Remove the second column, that means coefficients of y are eliminated, but we substitute by with the constants. See, here I am writing the delta 2. The delta 2 can be written as like this. Delta 2 is equal to, we can write delta 2 as this one, 1 4 minus 1. First row is as it is, first column is as it is, but the second column will be changed with constants, that is 505. Again 3 minus 1 1. I think you understand what I am doing here. Just I am replacing the only the second column elements with constants. There I can get plus, minus, plus this you may write eliminating 1 into this part 0 plus 5 again minus 5 into eliminating this one 4